I've made it in the same format as those test problems, and then I want to go over and kind of walk you through this. Now, the first thing you want to make sure that you are doing is reading the problem and deciding for yourself how this needs to be done. Don't be drawn into just like looking at the work I showed, because I'm kind of inconsistent in how I'm doing variables, throughout it. You need to read the problem and decide for yourself if this is a 2 mean problem or a 1 mean problem right off the bat. So here we go. For this one, we have 2 different firms that design their own version of the same aptitude test, and the psychologist administers both versions to randomly selected adult subjects with the results given below. At the 5% significance level, test the claim that both versions produce the same results. Okay, so based on the format that you see, would you envision this test being created with 2 separate groups, so we would have 2 separate means? Or do you see that we have a paired situation where I would then just be interested in 1 mean about the difference of those scores? Which one of those things do you think? What? 2 means? Okay, so you think we have a mean for the test 1 and a mean for the test 2. If I do that, if I have 2 separate means, I'm going to be really kind of, in a sense, comparing 2 different aptitude scores. I mean, I could, by random chance, get a whole bunch of people that have a high test score in group 1 and a whole bunch of people that have a low test score in group 2. So in order to alleviate this aptitude, just like your natural aptitude variable, you have the same people in both groups. So this is a subject A who takes the test 1 and test 2, and we see what's the difference in the same person's score on the 2 different tests. So, am I interested in 2 different averages? No. I am only going to make one line right here that is about the differences, okay, and then I'm going to get the average of those differences, and that's all I'm interested in. So, 1 mean. So that means, no pun intended, that the rest of this problem, you're going to have descriptions for 1 mean, conditions for 1 mean, histogram for 1 mean, defining the parameters for 1 mean. So here we go. In this first one, we got mu1 is the average aptitude test score, so on, and mu2. Do you see problems there? Is there a problem there? Yes, because I'm supposed to do it for 1 mean, so we will correct the problem. So the mu of 1 minus 2 is, and then you have to write the correct thing, which, what would that look like?
Average.
Okay, yeah, we're just defining the parameter. So the average, see, we're getting the average of the difference in aptitude test scores. And don't leave that hanging there. You need to define who this is for.
Will you tell us not to
You do not have to rewrite anything that's correct. You fixed the problem, so now you can fix that, okay? See, the instructions were unclear. So in aptitude test scores for, what population is this I'm talking about? All such adults. I always like to put such in there because then that means if there's any traits that they haven't told me, I'm saying the same kind of adults, whatever that is. All such adults that do what? Take both tests. All right. Next, here is the null hypothesis and the alternatives. So see, once again, I've returned to 1 mean here. How are we doing on that? Good? I'm thinking that there's a problem with the tail because this problem doesn't specify one test being greater or the less than. It just asks if they're the same. So are they different? So instead of being 1 tail, it should be 2 tail. All right, which actually kind of brings me to a discussion about this. I do not have intent of making these incorrect values here. You know, I didn't put something in wrong into my chart to make this be a wrong value.
What if you don't have
Oh, right. If you have one of these things missing, then that's bad. Now, let's see here. If you choose to do the pink problem, I will tell you that despite my best efforts, I actually do have incorrect numbers here on the pink problem, so don't worry about that. So basically the numbers should be okay. I'm telling you that so none of those little quirky errors mess up your problems, okay? All right, next, number 3. Random and independent. So random, stated for this group of adults. Oh, did I fix that over here? No, I didn't. Let me fix that. Sorry. Number 2, you may just fix the part that was wrong. You do not have to write the whole box over, so I can do this. And if you emphasize that that's the thing you fixed, that would be totally awesome. Okay, everything is awesome. So random is stated for this group of adults. Is that good?
Yes.
Okay, yeah, it is about one set. Look here at the independent. What's bad about this? This is about 2 separate groups. So, okay, so for this number 3, 9 is less than 10% of all such adults that take both tests. Okay, now, I have to tell you that I believe that I said there's only one mistake per box, and what I mean is if there are 2 things wrong in here, and I'm going to tell you straight up on some of the things, like this was wrong and this was wrong, or this was left off, okay? So if that's the case, then do not list this number 3 twice. Don't do that. If I had 2 errors in this number 3 here, then you would just fix both of them here. That's intended to just be one issue, one box problem. All right.
So if you don't put the other one here.
Sure. Yep. Okay, so now, number 4. This is not large enough. So my information to you is that these are not those are not being disputed. The things should be drawn pretty correctly. I mean, let's go with that they are drawn correctly. Now, you want to make sure that you draw the right amount of them. If I'm supposed to draw 2 of them and I only have 1 of them, then that could be an issue, and you would write that. Also, check your labels, make sure they're good. I don't think I messed up on those, just FYI, but some people kept asking me this. They said that I should write the word average here for the average difference, and that is not true, because what is actually being graphed here is one subject's difference, another subject's difference, subject difference, subject's difference. So these are individual subjects' difference, not average difference. Okay, so this is just difference, FYI. All right. So how about number 4? Are we all good?
No.
Man, did I erase?
You have to do your little thing that says unimodal.
Aha.
Metric.
Good. So number 4 has got a component missing, which is the unimodal, somewhat symmetric, which I'm just abbreviating here, but done on the test, and no outliers. Is the name of the test correct? One sample t-test for paired data? Yes, we decided we were doing this problem in a paired fashion. Next, I already told you I do not have intent on making these numbers messed up, so you don't have to check those. Now, as far as tailage goes, this tail should be correct for what it's supposed to be. So since this is a 2-tailed test, I mean, you could check in the calculator, but this should be correct according to 2 tails, not 1 tail. Okay, just FYI. I don't know where that went. It flew away, okay? All right. Now, next. Okay, there it is. Okay, that's fine. Okay, number 7. It's kind of like the hockey, the ice hockey, or whatever, whenever you do the thing, it just keeps going. Air hockey. So p-value, here we go. Greater than alpha. Is this a correct decision to fail to reject? The p-value is greater than alpha, so yes. All right, next. It is correct. In these boxes here, you are looking for things such as this. Wrong decision. This kind of wording is wrong. Here, like, I do or do not have evidence to suggest. Those are the kind of key things you're looking for to see if I messed up the conclusion with. Okay? So, for number 8, if I say, since the p-value is greater than alpha, I fail to reject, that was right, that the average difference, is this problem about the average difference? Is this problem about the average difference? Okay, in test score is not equal to 0. Is that what I am failing to reject? No, I am not failing to reject this. I fail to reject the null hypothesis. So see, there's a statement incorrect here. This should not have the not in there. So number 8 should read is equal to. Okay? Let's see if the last one is correct. See if this is a correct decision. Therefore, you don't know, I could have another box down there. Therefore, you don't see it. It's covered. I do not have evidence of a significant average difference. Okay, so I'm not having evidence of this. And that is an accurate statement, so it's all good. So, yes, you are right. There was no other box. And so, ta-da, we are done. All right, so I'm going to give you back your tests for you to check them. And if you would like a whole nother